So our next example, we're going to have 2x squared minus 5x equals 88. So it's going to start getting a little bit more challenging. We're going to have to manipulate our equations. Now, what we didn't have to worry about in the last problem was that we were already in standard form. So we're going to rewrite the equation, EQN stands for equation, in standard form. And standard form is ax squared plus bx plus c equals 0. So we set the quadratic expression equal to 0, and we write in descending order. The quadratic term comes first, then our linear term, then our constant, and equals 0. Step 2, we'll factor. And then step 3, we solve using our zero product property. So I'm going to subtract 88 from both sides. 2x squared minus 5x minus 88 equals 0. I'm going to set up my two binomials so that I can factor. The only way to get back to 2x squared is with a 2x and a 1x. However, 88 has quite a few different ways. We have 1 in 88, 2 in 44, 3 does not go into 88, 4 goes into 88 22 times, 5 does not go into 88, 6 does not go into 88, 7 does not go into 88, 8 goes into 88 11 times, 9 does not go into 88, 10 does not go into 88, 11 goes into 88, and 11 is already listed, so these are all our possibilities. So we're looking for a pair of factors that multiply to be 88, but it's going to work out nicely so that when I do the outer and the inner, when I combine the outer term and the inner term, I get a negative 5x. So I'm going to try the 4 and the 22. I don't know why. I actually do know why. Because if I try and put the 4 there with the 2x, this has a common factor that the original did not have. So there was no common factor in the original. Therefore, I can't put the 4 there. If I put the 22 there, same thing. The 22 and the 2 has a common factor of 2. The original problem did not. So I'm not even going to try 4 and 22, which means I'm not going to try 2 and 44 either, because those are even numbers, and one of them would get stuck with this 2x right here. So it looks like we're down to 8 and 11. The 1 in the 88 is just too much of a large number that I'm going to have to subtract to get a 5. That's not going to work. So let's try the 8 and the 11. If I put the 8 here, I'm not putting the 8 there because that would have a common factor. See, you're getting better at this. You put the 8 here and the 11 right there. So now I need a negative 5, so my 2x times negative 8 will give me negative 16 plus 11. That multiplies to be a negative 88, positive 11, negative 8. However, the outer and the inner indeed is negative 5x. So we're going to set 2x plus 11 equal to 0 and x minus 8 equals 0. And you're probably going to get quick enough at this that 2x plus 11 equals 0 and x minus 8 equals 0. You're going to get x equals 8 pretty quickly, and you might get negative 11 halves pretty quickly as well. I'm going to show my work on that one though. So I have two answers. I've got x equals negative 11 over 2 and positive 8. Let's do another example. So here's another example. I've got x squared minus 12x equals negative 36. I really like this example. This is a good one. It seems like, this one's not going to be that difficult, and it really isn't going to be difficult, but it's got an unusual circumstance. First step is standard form. Standard form. So we're going to set this equation equal to 0 by adding 36 to both sides, giving us x squared minus 12x plus 36 equals 0. Now we're going to try and factor. So I'm going to set up my two binomials. The only way to get back to x squared is x times x, and then 36. I've got 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5, no, 6 and 6. And I need, because we're leading off with a 1x squared, I can just look at the factors that multiply to be 36, but add or subtract to equal negative 12. Well, multiplying to be a positive, but adding to be a negative, that means I'm going to have two negatives, right? They're both going to be negatives. So which pair multiplies to be positive 36, yet adds to be negative 12? Well, that's going to be this one right here. So we'll have x minus 6 and x minus 6. Sounds like I just repeated myself. X minus 6 and x minus 6. Well, that's because I did. X minus 6 equals 0 and x minus 6 equals 0 gives you x equals 6, x equals 6. Well, that's the same number. So our answer is x equals 6. So this case, we only have one answer. Now it's going to be very interesting when we start thinking about what this looks like graphically. What does this look like graphically? We know that solutions look like x-intercepts, and we're going to talk about that. Now, in future math classes, when you get the same answer twice, you get a duplicate. They write x equals 6, and then they put multiplicity 2, which means occurs 2 times. So the answer of 6 occurred twice. Once, twice. But for Algebra 1, we just need to write x equals 6 and then just kind of think, all of the other examples gave us 2 answers, but this one only gave us 1. That's going to be interesting, and we will pull it all together. In the next video, I'm going to give you a try and see if you can factor the try. Now, it's going to have a greatest common factor, and it is going to be a little bit more challenging, so I encourage you to not skip over that video, because that one's really going to tell you if you got your factoring